We are going to the important discuss the points hyperfine splitting in ESR spectroscopy or EPR spectroscopy or EMR spectroscopy. The hyperfine splitting is very important. The hyperfine splitting is the special features of ESR, uh, ESR or EPR. What is meant by the hyperfine splitting? The hyperfine splitting means the interaction definition. The interaction between interaction of electrons interaction of electrons or electron spin interaction of electron spin with 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 a magnetic magnetic nuclei in the sample in the sample. Okay. That means the in hyperfine splitting the interaction takes place between spin of electron and spin of nucleus of the paramagnetic material, paramagnetic sample. From this is definition to indicate that the this interaction of electron spin with magnetic nuclei in the sample, the magnetic field separation between two neighboring peaks in the that means the magnetic field separation between two neighboring peaks in the splitting to the same nucleus is called as the hyperfine splitting constant of the magnetic nucleus. Hyperfine splitting constant of the magnetic nucleus. This is the interaction between the electron and the spin of the nucleus. Okay. From this interaction, the spin of electron, the, the interaction takes place. That is the multiplicity. From the spin multiplicity, the multiplicity of the electron as well as the nucleus. For a radical having equivalent nuclei, these are two types of nucleus. One is the equivalent nuclei and non-equivalent nuclei. In general, equivalent nuclei, the equivalent protons and non-equivalent protons. Okay, the equivalent nuclei, each the spin of nucleus, that is the spin of nucleus is represented as an I. The spin of nucleus and spin of electron is S. Spin of electron is the S and spin of nucleus I. Is the number of EPR lines is expected as is 2 Mi plus 1. 2 Mi plus 1. And Mi is the number of equivalent nuclei, number of equivalent nucleus or number of protons is maybe Ni 2Ni plus 1. N is the number of equivalent nuclei. Equivalent nuclei means equivalent protons or equivalent in general. What is the equivalent nuclei? Non-equivalent nuclei, equivalent nuclei. It is represented as the 2Ni plus 1. N is the number of equivalent nuclei. I is the spin of nucleus. Spin of nucleus. Spin of nucleus. Okay, this point. Suppose this is the energy of spin of electron is plus minus 1. This splitted into minus 1 and plus 1. These are two spins. Energy levels. M is minus 1 and plus 1. These energy levels. These energy levels is interact with the spin of nuclei. These energy levels minus 1 up, this each energy levels interact with the spin of nuclei by using this formula. Okay, each line is again this interact with the Mi. This is the interacts with MS is interact with Mi. This is the MS is interact with Mi. Is these energy levels is to get the spin line number of lines. Okay, this is the by using this 2Ni formula. For example, methyl radical. For example, methyl radical. CH3. This is the methyl radical. This is the methyl radical. In methyl radical has 3 nuclei, protons. Has 3 nuclei. Has 3 nuclei. By using this formula, 2Ni plus 1. 2Ni plus 1. Here N is the number of equivalent protons. Is 2 into 3. I is hydrogen have a spin. I is equal to 1/2 spin. This is the hydrogen has the 1/2 spin. Spin of nucleus, not spin of electrons. And therefore I is the 1/2 spin plus 1. And therefore is 3 plus 1 is equal to 4. This 4 is the 4 lines. 4 lines. Okay, these 4 lines. Okay, 4 lines is MS, and these 4 lines is this is known as this is the MS and this is the Mi. Each lines to get the 4 lines. Okay. Yeah. Also this gets 4 lines. This is also known as the 4 lines. This is this MS and this is the Mi. Here MS and Mi is the interaction takes place, and this interaction between spin of electron and spin of nucleus is known as the hyperfine splitting. This is known as the hyperfine splitting. Okay. For radical having a equivalent nuclei which with the spin is 1/2 equivalent nuclei can with the help of the spin the number of lines expected. If the non-equivalent nuclei is the if 2 Ni1 plus 1 and 2 Ni2 I plus 1. If the 2 this is 2 Ni1 means 1 nuclei and 2n2 means second nuclei is multiplied. This multiplied by using the, and you get the number of lines. Okay, this is known as the how to calculate the number of lines for the equivalent nuclei and non-equivalent nuclei. Okay, yeah. And therefore the rules for rules for the to determine the nuclear spin. For example, nucleus with even number of protons and even number of neutrons. Even number of protons and even number of neutrons. Even number of protons and neutrons has a zero spin. I is equal to 0. Then nucleus having with odd number of protons and odd number of neutrons. Well, odd number of protons and odd number of neutrons has integral spin. As the integral spin, for example, yes, the integral spin is 1/2, 1, 2, 3. Okay, this is uh, the so I is equal to 3. If the nucleus having odd number of protons and odd number of neutrons has the integral spin, is okay. The nucleus with odd mass and half integral spin is the I is equal to 3/2 spin. This is the 3 by spin. Yeah. For example, the nucleus spin quantum number or spin, the nuclear spin can have several orientations. For example, the I is equal to 1. I is equal to 1. I is equal to 1. The spin orientation is 1, 0, -1. I is equal to 1/2. If the I is equal to 1/2 is plus 1/2 and minus 1/2. Plus 1/2 and minus 1/2. Like 3. If the spin is 3, this I is equal to 3 is plus 3 plus 2 plus 1 0 minus 1 minus 2 minus 3. These are the orientation of the spin. Okay, if the 7/2 is, if the nucleus spin is the 7/2, the spin orientation, the nucleus of the orientation is plus 7/2 plus 7/5 plus 7/3 plus 1/2 and minus 7/2 minus 5/2 minus 3/2 minus 1. The total, the orientation is calculated by using 2i plus 1. 2i plus 1. How many orientation takes place in the spin of nucleus is calculated by the 2i plus. If the 2i, if the spin is I is equal to 2, the total spin is 5. Okay. Plus 2 plus 1 0 minus 1 minus 2. Okay, this is known as the 5 orientations, and this 5 orientation is calculated by the 2i plus 1. For example, one unpaired electron has ms is equal to plus 1/2 spin for hydrogen interacts with its nuclear spin. The I value of hydrogen is 1/2 I value of hydrogen is 1 half. It is plus minus and plus minus Mi, Ms and Mi. This Mi is equal to plus 1 half and minus 1 half spin. And each Ms state will interact with the Mi value and spin into y plus 1. The energy of, okay, this is the Ms. This is the yes. This is Ms value plus minus 1 half and plus 1 half. Okay, this is the spin of electron. If the Mi value is interact with each state, that means 2I plus 1, 2 into 1 half plus 1, therefore 2 lines. Therefore here 1 half, 2 lines. This is the Mi value. Yes. Okay. Plus 1 half and minus 1 half. This is the transition. Same is minus 1 half and plus 1 half. This is the transition. Is plus this transition is plus 2 plus and minus 2. This transition takes place. Yes. And that means 2 lines obtained. This is these are the lines 1 and 2. 2 lines obtained. 2 lines obtained in the hydrogen. The energy of particular image state will be affected by the nuclear spin and electron spin interaction of energy, and this energy is varies with product of Ms and Mi and given by A Ms Mi, A Ms and Mi. This value A is the constant value. A is the constant. A is the Hyperfine splitting constant. This is also known as the Hyperfine splitting constant value. The energy of different energy levels is given by is E is equal to G B Ms plus A Ms Mi. Yes. G is the gyromagnetic ratio, B is the magnetic field, and Ms is the spin angular momentum, the quantum number of the electron, and A is the Hyperfine splitting constant, Ms and Mi, the spin angular moment of the nuclei and spin angular moment of the electrons. From this equation, you can calculate the energy of the energy levels of the nucleus. Okay, and this the Ms in general, Ms plus 1 half minus 1 half plus 1 half and minus 1 half. This is the Ms value, and for the 2 lines, the minus 1 half plus 1 half, this is known as the Mi, and minus 1 half, this is plus 1 half. Okay, yeah. Here equal is one transition, this is the second transition takes place, and this graph is represented as the second derivative. This is known as the second derivative of the spectra of the hydrogen atom. For deuterium, this is for the hydrogen spectrum. Hydrogen spectrum. For deuterium, in deuterium, it has one unpaired electron. Deuterium is H2 radical. Is also one unpaired electron, which are interact with the nuclear spin, and therefore the deuterium is the nuclear spin value is the 1. Ms is equal to plus minus 1. That means S is equal to 1 and Ms is plus minus 1 in deuterium. Deuterium is represented as D2, is that means H2 radicals. H2 radicals, and I is equal to is 1. That means Mi is equal to plus 1, 0, minus 1 is value. In deuterium is total number of lines. The orientation, this is the orientations, is 2I plus 1. I is equal to 1. That means 1 plus 1 is equal to 3. That means 3 orientations takes place. These 3 orientations, okay, 3 orientations is interact with 2 Ni plus 1 is equal to 2. Okay. This is the or plus 1 and minus 1 EMS value, and each value is splitted is 3. Okay, each value is splitted into 3. That is 1, yes, minus 1 plus 1, 0, minus 1, minus 1, 0, plus 1. Okay, these 3 orientations is plus 1 to plus 1. One line takes place, 0 to 0 second lines, and minus 1 to minus 3 lines. Okay, these 3 lines with the spin I, 2 Ni, N means number of 1. Okay, 2 Ni plus 1 means 2 into 1 into 1 plus 1 means total 3 lines. 3 lines obtained in the 3 lines obtained is plus 1, 0, minus 1. 3 lines obtained. Okay, for the deuterium spectrum. Okay, one more example is studied for the ESR spectroscopy. This ESR spectroscopy is the applications of ESR spectroscopy is the non-destructive technique. The applications of ESR is the oxidation reduction process, also used reaction of kinetics, the some of the biological applications like the active sites of the metal of proteins. These are the applications of ESR spectroscopy. So many applications in ESR spectroscopy. Energy transitions, the hyperfine interactions. Yes. The hyperfine splitting by using the Pascal's transitions is 0 power 1 transitions, 1 power 2, 2 power 5 transitions, 6 transitions. Okay. For the that is the relative intensities of the ESR spectroscopy. You remember the how to calculate the number of lines in the ESR spectroscopy. Okay. Thank you.